It's my pleasure today to introduce our speaker, Ted Gibson of the Department of Brain and Cognitive Sciences and the Department of Linguistics and Philosophy at MIT. Ted comes from a background in computational linguistics, where for his PhD he worked on building computational models of sentence breakdown, and also garden path effect. Since his PhD, he's continued to work on computational modeling and sentence processing, as well as language acquisition. And his research agenda has really exploded in looking also at empirical questions and doing very careful and interesting experimental studies of questions in sentence processing. So today he's going to talk to us about some of those empirical results and their implications for a model he's been developing. And so we're happy to have him here today.
Thanks, Bob. So the title of my talk, Resource Demands and Sentence Complexity. I've been bothered for a long time about how we understand sentences. So how it is that we put the words together to make a complex structure for some sequence of words. So how do we process sentences? Well, sometimes the context helps. So if you got some objects in your discourse, they can help you. So pass the book on the table, you can use those to refer. But sometimes the context doesn't help at all. I can tell you crazy things which are just completely implausible, like giant lizard-like creatures are descending from spaceships and attacking Boston, where clearly the context isn't helping at all. Or even crazier things. A man with below average intelligence will someday become the leader of the most powerful nation in the free world. Things which you would never expect anyone to say, and yet you can understand me perfectly well. And
this room is bugged. You should be aware.
I've given that talk to Lincoln Lab people, and they were the only ones who didn't laugh. Their government. Just that exact thing. It was like the only group who didn't laugh at that.
They really didn't laugh?
No, nothing.
That's bad.
Nothing. Yeah, I commented, wow, this is the only group that didn't laugh, and they laughed at that. So I guess they were feeling self-conscious. So there are lots of sources of information that people use understanding sentences. Word frequency. More frequent words are easier to understand than less frequent words. And that's an important factor. Plausibility. What things mean in the world, the meaning of a structure in the world, of a sentence. So the dog bit the man is a plausible thing. It's easy to understand. The man bit the dog is kind of weird, right? And so people read these things slower. They have more difficulty understanding implausible things compared to plausible things. So frequency, you have more trouble with less frequent than more frequent things. In each of these sources of information, we can measure things in two ways in experimental approaches to figuring out how we understand sentences. One, we can look at unambiguous things. Because unambiguous sentences like these, which are kind of unambiguous, and people will read that slow compared to this one, and we can infer that's probably something to do with the plausibility. We can also look at ambiguity. Language is extremely ambiguous, and when you're given choices about, you make two different structures or two different meanings for a word, one's really frequent, one's really infrequent, you'll choose the better one. In this case, the really frequent one, the more plausible one. So that's two ways to go at what sorts of information are being used. One's ambiguity, one's unambiguous structure, unambiguous things. There's at least many sources of information which affect our understanding of sentences. The discourse context matters a lot. What's in your local environment, the things in your visual environment, but if I'm talking about reading or listening to sentences and I got no visual environment, the things that I mentioned last, so the stuff in the story that have been introduced. The thing I'm going to talk about today, the word order. Syntactic structure also affects the complexity, the difficulty, the simplicity of what makes something easy or hard to understand. Okay, I spent a lot of time on that. So, but roughly speaking, working memory. Okay. In your working memory, you've got a finite capacity working memory, and I'll talk about how to elaborate that. So different word orders are easier or harder than other word orders. Okay. Also, another source of intonational information, auditory processing. Some intonations are easier, harder to understand than others. And so none of those other factors. Oh, so there's a whole pile of factors here. An interesting question, one which I'm not going to pursue, is how do they interact? there's a lot of research out there that suggests that like the most recent stuff suggests that a lot of all these sources of information are basically are available as soon as you can measure. But that's a question of how at least they're all available immediately. Maybe. I mean that's a hypothesis out there. That's not what I'm not going after that though. I'm just going to go at this question, this source of information, and how we can measure it, how we can talk about it empirically. Okay, and there might eventually be computational applications of this kind of work. So my background, as someone mentioned, is computational linguistics. As Bob was telling you, I did computer science undergrad, and I wanted to do like automatic translation. So eventually, I thought that if we know what makes sentences easy to understand, that'll be good in generation. You'll be able to produce. You want to produce things which are comprehensible. So it's motivated by in machine translation. You want to produce things which are understandable. A second application of this kind of work is in something like style checking. You want to, so Microsoft has their little in Word. There's a style checker in there which does something actually pretty reasonable, but it's using some particular heuristics. You might want it to model what humans do a little more closely. Okay, those are and maybe in ambiguity resolution, information retrieval. These kinds of things might be useful eventually, but I think they're kind of noise. For current applications, because the applications are so, they're just trying to get, they need to get the plausibility information first. Okay, so what I'm going to talk about is working memory and sentence comprehension. And I got a particular theory here, which I call the dependency locality theory. It's basically some hypotheses that we're going to end up testing. Okay, what's working memory? Okay, working memory's got sort of two components, roughly speaking. You've got a storage component, and you've got a processing component. So, in work on old research in experimental psychology, I guess there are two things. There's storage, so we got to keep track of, let's say, a random list of digits, a phone number. That's a storage component to working memory. Second component is a processing component. Say I want to do like some mental arithmetic, do some multiplications of 3-digit numbers in my head. Well, you got to keep track of something, but you also have to do something with those digits. So one's a storage component, and there's a processing component to working memory. Well, language, a lot of tasks, including language processing, have both of those components too. So one of those, you need some kind of computational resources for both for storage and for computation for integration. So I'll quantify those. I'll make some hypotheses about what storage is. Storage may be predicting categories to make grammatical sentences. You're keeping track. So if I'm listening to a sentence, you're reading sentences, you are keeping track of what you need to make a complete sentence at every point. You are making you get expectations about that I'm going to speak grammatically to you, that I'm going to speak in sentences to you. I'm not going to give you partial sentences, or at least it's okay as answers to questions. But if I say something like the claim that the reporter lost the money, you're expecting a verb there. I need a verb for claim eventually. Okay, as opposed to an answer to the question. So there's some sort of expectation for grammatical sentences. What are those? And I'm going to quantify that in predicting heads to syntactic heads to make a grammatical sentence. There's other ways you can quantify that, which are interesting, and I'll talk about later. Integration is the processing component. That's where I get a new word. I've got some expectations. I've got a representation for the structure I've built so far, but I've got expectations as well what I'm going to hear. And now I'm going to get that new word. I have to connect it to the structure that I've built, and that involves retrieval. That involves some kind of retrieval of the element which I have to do the connection to. So there's something, say it's a subject-verb agreement. I say I get my verb for my subject. I have to find that subject out of that structure that I was listening to, that I was hearing. And there's some difficulty, there may be some complexity associated with that, depending on how far it came back, how far back in the input it was, how much stuff happened in the meantime. So those are hypotheses. And again, the evidence that I'm going to provide, actually it's going to come mostly from processing ambiguous structures. Okay, but in fact we could look at ambiguous as well. I'm going to look at in reading, I'm going to look at people's online, word by word reading performance for unambiguous structures for the most part here. I mean, sentences which are, there's always some little temporary ambiguities, often, and most like, I'm going to try to construct these sentences so there's very, very little of that, and try to look for evidence of storage and integration in unambiguous structures. You can also, we have lots of evidence in the processing of ambiguity as well. I'm just not going to go through that stuff today. Okay. So here's a puzzle that needs to be explained by a theory of word order, a word order complexity, syntactic structure. Why are nested structures so hard, or nested or centered or embedded structures? Why are they so hard to process compared to their controls, their right or left branching controls? So here's a nested structure where I just start with the reporter disliked the editor. I can put a relative clause between reporter and disliked and get the reporter who the senator attacked disliked the editor. But if I do that again, the reporter who the senator who John met attacked disliked the editor, that's really hard to understand. And you can compare it to a sentence like John met the senator who attacked the reporter who disliked the editor, which is the right branching version of this nested counterpart here. And this has all the same words, all the same plausibility, all the same thematic relations between words. So all those factors, other than syntax, between these two are pretty much controlled. You get the same words, so it's not lexical frequency. It's not the plausibilities of the situations in the world, because it's exactly the same situations in these two sentences. The word order is really different. Okay, the word order in the nested structure is very different from the right branching structure. Why is this so bad? Well, I'm going to tell you a couple. So part of it is, there are two components to that. The answer, well, an answer which I think is compelling, is that one, there's a storage component. So when I'm processing along here, the reporter who the senator, I'm expecting a verb for a reporter here, and I'm expecting some empty element or some verb or something for this who. I'm expecting another thing for this subject. I'm expecting something for who. I'm expecting something for John. At the point of processing John, I got a whole pile of unfulfilled expectations. That's a big storage component, quantified in some way. And I'm talking about predicted categories. Okay? And furthermore, when you do the integrations, when you actually do the connections, there's a lot. They're a long way back. I mean, it's not too far from met back to John and who to met. But look how far it is for at attacked. I've got to hook up who to attacked, and I've got to hook up senator to attack. There's a couple of really long distance integrations here, connections to be made here, and then there's one long integration being made between disliked and reporter. So there's one really long one, two really quite long ones here. So basically, in nested structure, and if you compare that to the control, the right branching, in both of those, both storage and integration, there's not much going wrong here. Basically, I need a verb, I get a verb. I need a noun, I get a noun. And I could be finished here. John met the senator. Then I get a relative pronoun. I need a verb, I get a verb. And so you get only one predicted category, and then it gets resolved immediately. So few unresolved dependencies, and they're always very local. So there's two components. Now, how are we going to? Why do I think there's two things as opposed to one thing? Well, reaction times tell you a lot more than. I mean, you might just think, well, one of those factors would have been fine to explain this difference here, but in order to explain the online behavioral language understanding process, turns out that you can separate both. You can separate the two things, storage and integration, and it looks like they're both contributing, not on top of each other, not just one to explain both. Okay, and it's just it turns out across languages, all languages, if you have a nested structure, it's hard. Non-nested counterpart is relatively easy. So Japanese is a verb final language. So the verbs all come at the end. And so if you do something like, my aunt thinks that the babysitter said that my older brother bullied my younger sister, in default subject, object, verb, word order in Japanese, you get something like aunt, babysitter, older brother, younger sister, bully that said that thinks. It's impossible. That's the Japanese version. It's just like the nested English version. We can make it a lot easier by unnesting it a bit by just basically taking the subject here, this topic, and putting it next to its verb, which is this one down here. Okay, and then it's unnested a little bit and becomes a lot easier to understand. In fact, we have reaction time evidence. If you unnest those things, they become, just like their left branching structures, they're easy. Okay, just like every language, that's true. So what do I want to talk about now for the rest of the talk? That's my little intro. I want to do talk about integration first in unambiguous English sentences. Give you some reaction time, reading time evidence for just this hypothesis that I was telling you, longer distance dependencies give you difficulty at words where you have to make those, where you have to form those dependencies. Then as soon as I say that, well, you say longer distance, what do you mean by distance? How do you quantify that? And that's a very interesting question. Okay, so is it words? Is it time? Is it a lot of different things? Well, it turns out our first hypothesis has something to do with discourse structure. I think that maybe still right. There's basically the complexity of the discourse stuff that you have to build in the interim between two dependencies. Along those lines, maybe the accessibility of the types of noun phrases in between. Basically, pronouns are extremely accessible things in between. But other kinds of noun phrases, depending on what they typically represent, so names are typically tend to be kind of accessible things, but other kinds of definites are less accessible, and indefinites are new entirely. Those become less and less accessible. So you might get, well, in fact, you do get. There's a reason why I'm telling you this. Is that's what happens. You get longer and longer reaction times depending on how typically accessible the kinds of noun phrases are in between. Okay, you see that. And then there also may be a compounding effect of the similarity of the kinds of noun phrases in various forms, counting similarity, syntactic similarity, or maybe and also possibly semantic similarity of the kinds of things that come in between. These all are questions about distance formulated in the integration idea. Okay. Then I'm going to tell you about storage a little bit, looking at unambiguous English constructions, just show you that independent of integration, when we control for integrations, exactly the same integrations going on in two sentences, you can see effects of storage. Basically, people go slower when you've got more pending dependencies. And then there's questions like, well, what kind of dependencies? All kinds of open dependencies, and so far the answer is probably yes. It looks like any kinds of open dependencies, not just verbs, but if you keep open a prepositional phrase you need, if you keep open some sort of an empty category for a who, you need that hurts you a little more than not having that, well, significantly more. And then finally, I'm going to talk about, I hope, depending on how my time goes here, on predictions of this kind of resource account for processing some elements of different languages. So Chinese has a cool word order with respect to English, which gives some neat predictions. Chinese is SVO, subject, verb, object, just like English, but relative clauses happen to come before the head as opposed to after the head. So in English, you say, the man, who I met yesterday. But in Chinese, you say, who I met yesterday, the man, which isn't so extraordinary across languages, except that it's an SVO language. So it's generally verb initial, and yet it's head final for relative clauses, which is very peculiar, which is an interesting question. I don't have any observations on why it's like that, but because it's like that, it offers an interesting way to pull apart some different ways to think about resources from other things. So I'll talk about that briefly as well. Okay, and there's tons of collaborators on all these things. This is very, doing a single experiment takes a long time. At least sort of 6 months of intense amount of work preparing materials, which are controlled for all the factors we don't care about, which are lexical frequency and plausibility and discourse context, and all these things. And then running lots of subjects. So, because people's experience in the world is so different, you've got to average across a lot of different items, a lot of different materials. So it takes a long time to do each one of these things that I'm going to tell you. And so Dan Grodner, he's now a postdoc. These are graduate students in my lab, but he's a postdoc at Brown. Tessa Warren is at UMass Amherst. And Dwayne Watson, Rochester. These are all postdocs. These are now current graduate students. Florian Wolf, Evan Chen, Tim DeSmet, and Franny Hsiao, and some more people down here also who are less involved in these experiments. The top ones are more involved. So. Franny Hsiao is the Chinese person. I don't speak Chinese. Okay, so the idea, this integration thing. Back to, so I'm going to try and do 3 things. So integration, longer distance, harder. Why should longer distances be harder? Well, the computational motivation is this retrieval idea. I've got some partial representation for the input as I'm listening or reading it, and I have to retrieve. And then when I get a new word, I have to hook it up. I have to hook it up to some piece that I've been saving. And to do that retrieval requires pulling it out of going across other things that I've been processing, which have been presumably taking up resources. Okay. Yeah, so that's the whole idea. It's basically, it's not a very difficult idea. The motivation, linguistic elements are perceived serially. You get them, sequentially, auditorily, or in reading one at a time. And your comprehension is incremental. You're building the structure as you're going. That puts working memory demands on you, and you can't hold everything in memory perfectly. Stuff well, either decays or there's a lot of interference from the stuff in between. It's hard to tell those two apart. Decay and interference are difficult to tell apart. Anyway, so you get it's well known that you get locality effects in ambiguous structures. So an example, like this old principles called like right association or late closure from the 70s. Example like the bartender told the detective that the suspect left the country yesterday. Yesterday is some sort of adverbial modifier which could modify leaving, the left, or told. And there's this really overwhelming preference to take it to the local thing, to when the leaving took place, not when the telling took place. And there's lots of experimental evidence. So that's ambiguous. It's a modifier could go to either place, and there's a really strong locality bias. So there's lots of evidence experimentally that that's the case. There's some interesting hitches and glitches that I can tell you about if you're interested. But certainly in multiple clauses, there's an extremely strong bias to go locally, experimentally. Okay. Okay. Before I give you evidence for looking at unambiguous structures, I need some hypothesis about how to measure distance. And I'm just going to say, let's count. I've got a lot of junk written up there. Let's count nouns and verbs in between. I could count anything. I could count words in between dependencies. I'm going to count nouns and verbs for starters. And this is just an initial hypothesis. Maybe the difficulty of the integration depends on discourse structure for the new thing, and the difficulty of all integrations in between. Well, our simplifying assumption might be that it's proportional to the number of discourse things in between that we had to build. Okay, because there's evidence from the psychological literature that building something new mental model is kind of computationally costly. So that's a first guess. I mean, there's lots of other hypotheses you could have. It turns out they're going to be completely confounded in the experiments that I'm going to talk about. Just want to show the effects of distance. Okay. So the first experiment just looks at relative clauses, object extracted and subject extracted relative clauses. Object extracted, the reporter who the photographer sent to the editor hoped for a good story. So here we got who coming out of the object position of sent. Compare that to the reporter who sent the photographer to the editor hoped for a good story. Here, who is right beside sent, subject extraction. And so I can take those two sentences, and here are the dependency structure. Here's something about the dependency structure for those two sentences. There's reporter, the reported. I don't have any phrase structure trees here. This is just dependencies. I'm not relying on any particular theory of phrase structure grammar, just dependencies between words. So this is a local dependency, and I'm going to count that as a distance 1 because we've got one new thing, one new noun head reference since the. Who is not a new thing. It's a pronoun which refers to reporter. It's a local integration hooking up to the previous word. Depending on whether you do some sort of incremental processing or not, you can hook it up to the or not. Anyway, but the dependency is with the photographer, and there's a distance 1 there. At sent, we got a lot of action. So the reporter, who the photographer, we've got a lot of local integrations all the way along. At sent, we have to hook up sent to photographer. That's a subject-verb integration, so there's some sort of thematic role assignment going on. Sent is there's some agency going. This is the agent of the sending. But also the object position of sent is who, which is coindex with reporter. That dependency, that's this thing here, crosses sent and photographer, two things that have been introduced in the discourse since then. So that's why I'm just, so distance 1 here, length 1 here, length 2 here, total of 3. You can count in some other way. You can count words. You just get a bigger number there. That's all that's important. So sort of small, big number here. Then local. Now you get another big number here at hoped because there's a lot of junk back since reporter. And I'm counting nouns and verbs. So I'll count hoped, editor, sent, and photographer. That's 4 things since reporter. So that's how I'm doing my counts. They're completely confounded with lots of other ways of counting distances. The subject integration, subject extraction, it should be kind of clear. Here we've got, it's local. Between who and sent, it's local. And you got a bunch of local integrations, except again between reporter and hope. So the prediction is, that if these integrations matter in online reading, you should get long reaction times at hope here and at sent and hope in the previous case, but not at sent here. So not all verbs. If you've got a local integration between the verb and its preceding noun, that's not going to be hard. It's only if you've got some longer distance connection. And I should tell you about the method. A lot of our materials are gathered using a self-paced reading method. So people sit at a terminal and they get a string of dashes like this. in front of them, and they have to hit a key, and when they hit a key, the first word appears, and then then they hit the key again, it's just say space bar. The next word appears, the previous word goes away. You get the idea. So it's like this: Mary criticized John's apartment, so he knocked her flat. And we don't typically ask crazy questions like that, crazy sentences like this, but did John, and there's a question after each sentence to make sure people are paying attention, because some people are motivated by the $10 we pay rather than to help us out while do the task, and so we don't want if they get 50% accuracy on which is chance on yes/no questions, we don't really want their data. That doesn't happen very much. Most people who come in really do want to do the task. So you get.
What's the answer to the question?
I don't know. That's a crazy. No, we don't ask stuff like that. Is it no?
It depends on whether you've written in the U.S.
Yeah, yeah. It's ambiguous. It's totally. We wouldn't ask a question about a lexical ambiguity or any kind of ambiguity where it's actually globally ambiguous. Where we'd have to allow people to answer either one in that case, yes or no, if that's true. It's just for a joke. So the reporter who sent, what I've got here is mapping. On one axis, I've got the reaction time. So typical reaction time per word is around 250 to 400 milliseconds per word is a sort of typical reading speed. That's actually true in normal reading, where you're just doing eye tracking, as well as in self-paced reading. It's a little slower in self-paced reading, where you're hitting these buttons, but not that much. So it's on the order of maybe 50 milliseconds slower. So here we've got an app. Well, these are like 350, 400 milliseconds per word. You get, and on the other axis, I've got the average distance across those regions, whatever the regions happen to be, of the dependencies. And so it's averaged between 0 and 2 or 2.5 or something like that, because I'm averaging over a bunch. So, well, at Cent, we have a long distance integration, right? And why did I put 2 together? Well, in self-paced reading, people, if you go slow on one word, it often spills over to the next. So this is sort of a limitation of this method. You don't see the effects only on a particular region. It's a little spillover, and it probably spill over to the third word. In fact, they do here, but it may not even. We don't know that. We don't know why the reaction times are kind of slow here. They could be because it's a spillover from the previous region, or it could be because some other reason we just don't know. Okay, so it's just not a good correlation there. But so that's why I'm averaging over 2 words here. So over points of high integrations and the following word, I'm putting those in a single region, and the rest of the time I'm just putting together sort of constituents just to not make it too long. Basically, you have fast reaction times everywhere, except for on the 2 verbs, and on that one, which is sort of unpredicted. That's not a good correlation in the middle there. And in the subject extraction, you got fast reaction times everywhere, except for on the main verb and the following word. And so overall, if you put all those points on one graph, that's the same axis, you get a nice correlation between reaction time and this integration cost. Okay, and that's a reliable, highly reliable correlation. But if you know something about correlations, that's maybe driven by some outliers. There's only 3 high points of integration, so you can worry that maybe we should have some more variation in distances. And so the second experiment that I want to show you is just doing that. We just look at a whole lot more distances. The details aren't really important, but I'll give them to you anyway. That the first one is the nurse supervised. We've got a local integration between a subject and a verb. And all I'm doing in the second one, the nurse from the clinic supervised. Just put some prepositional phrase between nurse and between subject and a verb. And then make it a relative clause. The nurse who was from the clinic supervised. And we also controlled these things for plausibility, so they're equally plausible with and without the prepositional phrase. So then we get increasing distances between nurse and supervised across these 3. So 1, 2, 3, if I'm counting nouns and verbs. Distance 1, distance 2, distance 3. And then I embed all those things in a relative clause. So it's now the administrator who the nurse supervised. I'm adding an extra dependency now each time because I've got to hook up who to its object position, not just the subject verb, but also the who to the object position in these cases. And so instead of 1 there, I've got 3 because that's a longer, the length 2 between nurse and supervised to who. And then the administrator who the nurse from the clinic supervised, there's a length 5 there. Then finally, the really unpleasant one, the administrator who the nurse who was from the clinic supervised scolded the medic or something. Okay, so, and we get along. That's unpleasant because, we will argue, we will show, in fact, there's really long reaction times here. people have a really hard time on these really high integration points. Okay, and so I can just do the same thing. This is across all 6 graphs. It's too much data to look at once. I don't know. Is there a good correlation? Well, it's kind of hard to tell. Look at that. Kind of maybe. Yes, if you put them all in one graph, there's a very high correlation between reaction time per word here. So again, between whatever 3 and 600 milliseconds. So those really long ones, that supervised thing in embedded case, people read it much slow, really slow, a lot slower than everywhere else. And that's the place where there's a really long integration. And now we've got a much wider range of difficulties, not just of distances. And in fact, if you just do word by word rather than region by region, things come out pretty much the same. So even in spite of the spillover problem, you get a very high correlation between reaction time and distances between. So 60% of the, that's not everything, but 60% of variance is a whole lot of variance to explain. Okay, that's not a trivial amount of variance. That's a lot of variance between in trials. So it's something. So the question. Okay, so maybe what's going on in nesting is this integration part of it. So maybe the reason that this sentence here, the reporter who the senator who John met attacked disliked the editor. Well, I know from this reaction time experiment that people are actually reading. They're having a really hard time reading that word and the following word. That's where you're actually experiencing the difficulty. Maybe caused partially by the storage, or losing the storage and having trouble doing the retrieval. But that retrieval process is really difficult right there as compared to the unambiguous control. So the locality account of this nesting is that nested structures have longer distance dependencies. Okay, and it turns out that there's lots of other structures cross-linguistically we can look at where we can sort of explain complexity effects in terms of distances. I'm not going to say it. So heaviness is one in case you know about heaviness. You like to put heavy things toward the end of a sentence in English. If you can, so you've got, like, say, a prepositional phrase, two prepositional phrases following after a verb. I like to put the big one later, and that follows rather than I could put it earlier. But if I put it earlier, then I end up with longer distance average dependencies, which is bad. Okay, locality account. Nested structures have longer distance dependencies. That's what I already said. Okay. An alternative is this storage idea. Nested structures have parse states with more incomplete dependencies. That's the storage thing. Well, here's some other cases where that doesn't work. There's a nested pronoun generalization that Tom Bever made first back in 1974. Examples like this are doubly nested structures, which are actually not very hard to understand. The reporter, who everyone that I met trusts, said that the president won't resign yet. That's actually doubly nested, just like those other kind of case I had before, and yet it's quite interpretable. And Bob Frank has another example. A book that some Italian who I've never heard of wrote will be published soon by MIT Press. That wasn't Luigi, was it? I don't know. Anyway, so that's not a very easy sentence to understand, in spite of the fact that you've got subject, a book, some Italian, a subject, and a third subject, I. Why are these structures so much, intuitively, they're much easier to understand? Why are they so much easier? Well, our idea about why they're easier to understand is that there's a pronoun in the most embedded position here. Turns out all the doubly nested structures, which sound pretty good, like these, always have a pronoun in the most embedded position. It's always I, you, or we. And so one possible reason why they're not so bad is that distance is sensitive to discourse structure, and those pronouns don't count for distance, or much less than other new discourse reference. And so when you have to do the integrations further on, like at trusts and said, it's not very hard to go across those. Okay, that's the hypothesis, but you need to test it. We actually tested it experimentally on examples like the reporter and the senator who you met. The previous examples are not minimal pairs at all, so the other kinds of nested structures I was looking at, so we need some minimal pairs. The reporter who the senator who you met attacked just like the editor, the reporter who the senator who John met attacked just like the editor, the reporter who the senator who the professor met attacked just like the editor. If you get the intuition, this one should be easier than the other two. The U case should be easier than the other two. I mean, I still get it after all these, and it is. We didn't do it online here. We just did a rating. We had people just questionnaire which of these sentences sound, no, not which, just rate how difficult this particular sentence is. And complexity ratings, the pronoun cases are rated as much easier to understand then either the proper name cases or the definite descriptions. There's no difference here between these two. There's some tendency, which is not at all significant in this case. I'll elaborate. I'll pursue that a little further in a minute. There may be something there, in fact. Okay. So this is it. We're going to start right now. So how do you quantify distance? Well, maybe discourse structure. Having old things to discourse may not count against you, but having new things hurts you. So that's discourse structure idea. But it may be more general than that, or this is maybe, so maybe the accessibility, the types of the embedded MPs matter. So the function of, in particular, the function of a restrictive relative clause, which all these are relative clauses, is to pick out some element of a set, right? So when I get a relative clause, I'm trying to pick something, it's the boy who passed the test. Well, it's which boy is it? I've got a bunch of boys. I'm picking out the relevant one, the one who passed the test. So people will expect familiar kinds of noun phrases in order to help you do that picking, the picking elements out of a set. And pronouns are, extremely familiar. I mean, they are the most accessible kinds of things you can have. I, you, we. But more generally, not just pronouns, but there's a continuum here. Names typically refer to more accessible things than. When you use a name, when you use a pronoun, it refers to something which is highly accessible in discourse. When you use a name, it's referring to something which is, quite accessible, as opposed to when you use some sort of definite description, which is referring to something which is there in your mental model of what's going on, but it's not very accessible, as opposed to an indefinite, which is entirely new. Okay, so there may be a continuum according to the accessibility of the type of the noun phrase. And there's another hypothesis, which is orthogonal, which I'll come to in a second. Maybe it's maybe the kinds of noun phrases in between may interfere with one another, and I'll come back to that in a second. So I'm going to explore this accessibility idea. So this is Gundel et al. And Ariel have proposed what I just told you, given this hierarchy. Basically, that you refer to elements when in the corpus analysis they inferred that people use pronouns to refer to really central, highly accessible things. I mean, it's intuitively seems highly likely as well here. So you refer first names to things which are kind of accessible, full names to less, and then definite MPs which are more and more peripheral, less accessible, and indefinites are sort of off the scale because this was only talking about things which are already there. Indefinites have to be introduced altogether. So this accessibility-based theory predicts that you get greater difficulty for processing the more peripheral, the things off to the right there, especially these nested positions. And that's something we tested a couple of times. So this is looking at, I think I want to skip this. I mean, I'm just going to make the same point a bunch of times. I'm just going to jump to the online one, which is a little easier. These are just doubly nested versions. Now I'm going to go to the singly nested versions. It's just an easier version of this. So the benefit that we organized raised $200,000 for cancer research. The benefit that Dolly Parton organized, the benefit that the celebrity organized, or the benefit that a celebrity organized. So here I'm just moving along the hierarchy: highly accessible, less, even, least. And what you see in reaction times in the embedded region here, we got the same kind of things. It was ratings of whole sentences, and there was 6, not just 4. And we controlled for plausibility as other factors here. Through these two verbs, the embedded verb organized, the main verb raised, you see the definite description. That's this one here. It's numerically and significantly slower than some of those other ones. Numerically slower than all of them. So that's the indefinite. Sorry, the definite. The name. This is the name and the pronoun. So numerically, you got this pattern fitting the accessibility. Not all those. If you average across those two words, some of those comparisons are significant, and others, but not all of them are, but a lot of them are. So it's sort of generally fitting the pattern. Yeah.
In this case, the pronoun does not introduce any ambiguity.
Yeah.
Is that the conclusion valid if there's some ambiguity introduced by the pronoun?
No, there's nothing about ambiguity here. We're trying to make these things kind of unambiguous.
I understand,
but
using pronouns, right? In some cases, the sentence might become ambiguous.
Yeah. So we always use first and second person pronouns in these null context cases. We're always using, so the null context means there's no sentence before them. And so in those cases, when I'm talking about pronoun, I always mean first and second person pronoun because it's kind of weird. It's not felicitous to have a third person pronoun without a referent, right? And so they don't have cases like that. In fact, in the previous, because they're always first and second. I mean, there shouldn't be. I mean, there is some kind of ambiguity there still in that we don't actually know who we is. You know, who is we? Is it the writer? Is it you as a reader, or are we? Is it we inclusive? Is it we exclusive? There is some sort of interpretive ambiguity there, which does not contribute to processing difficulty. Basically, people read that those words extremely fast. That kind of ambiguity does not have. I don't think that's what you meant, though, right? You meant just the ambiguity about a he could refer to multiple things. Okay, that's just not the case in these cases. In the previous,
it would be interesting to test, right? Because, I mean, given your theory about why the pronouns are easier to process, maybe these would be pronouns that wouldn't be easy to process if you provided a context. John told Bill that the benefit that he organized.
That's getting a different question. I mean, I mean, it would be interesting. I mean, in fact, in the doubly nested version, one of our conditions was this kind of case right here. So we actually put a topic. As for Bill, the programmer was through the company which he founded and competed with, blah, blah, blah. So we actually did the third person pronoun. We tried to make it unambiguous, though, with no ambiguity. Not what you were doing there with John and Bill, just with one. There's a whole question about ambiguity and whether it makes you slower or faster. Having ambiguous structures, as I was actually talking to you earlier about this today, there's no evidence that having ambiguity per se slows you down. If anything, it seems to speed you up. If you have some sort of, as long as you don't resolve it one way or another, over either way, then in fact, in anything, it tends to speed you up as opposed to slow you down. And the way that people interpret that is that maybe this way you guys a serial parser, a serial processor, and as long as you can choose one good structure for what you got, you go fast, and you go slow when you have to. You stochastically make some choice and you're wrong, then you end up getting some reanalysis effect later. But I'm trying to make these unambiguous, okay? So that's sort of orthogonal to my materials, although it's a very interesting question. Okay, so we get these effects. So you get indefinite slowest, then definite, then the names, then the pronouns, roughly speaking. Here's another explanation of that. Of some of that, okay? What Peter Gordon and his group had as an alternative explanation potentially for this is that maybe it's not the more or less accessible of the NP type, but it's the similarity, the syntactic similarity of the intervening NPs with the head noun. So maybe the reason we were getting such slow reaction times here on organized and raised is partly because we're relativizing on a definite, the benefit. And that's sort of most syntactically similar to the celebrity or a celebrity. And so we're getting elevated reaction times for these two. And there's no explanation here of why the indefinite should be worse. You would just say that it isn't. They're pretty much they're syntactically the same. So that there's no. I mean, in fact, and they aren't. If you look at our data, they're just numerically different, and they're not significantly different. In fact, they may be different. We just haven't run enough subjects possibly on that. But the hypothesis is it's a syntactic similarity of this thing to this thing, and maybe semantic similarity as well, and these things are really different. Okay, and so an evidence for that hypothesis he provided in terms of, he basically set up clefs, and then not relative clauses now because you can't relativize off anything but a definite or an indefinite noun phrase. I can't relativize off a name. I can't say John, who Mary met yesterday. You can as a non-restrictive, but you can't do it as a restrictive. It's sort of less frequent, less good. But you can do it for clefs. So I can say it was the barber that the lawyer saw in the parking lot, or it was John that the lawyer saw in the parking lot, or it was John that Bill saw in the parking lot. Okay. What he did was a 2x2 here, manipulating the type of noun phrase in the head noun, either the definite or the name. And definite in name in the embedded noun phrase. Okay, and what he found was if they were the same type, people went really slow. So contrary to what I was saying, somewhat. Okay, so the name in particular were really slow, same as description, as the X, name are both are equally slow. And then when you have a mismatch, you go faster. And he also has controls for the subject extraction, which you don't get much stuff going on there. In the object extraction, is where you get all your stuff, your difficult integrations. Okay, so this is not explained. These data are not accounted for by that accessibility idea, because the accessibility idea would have predicted that if I got a description on the inside, that should make things easier. Whether or not there's a description on the outside, that should make things easier. And that's not what we're seeing here. We're seeing, in particular, description is, matching is just as, or name is just as bad as description. Well, I was very interested in these data because it was very counter to what we thought was going on. And so I don't know. I believe it if it's true, but there was some reasons to be worried. The method is a little odd. Basically, it's a centered screen presentation as opposed to less normal reading. Okay, I was showing you sort of this moving window approach as opposed to centered screen. I don't know if that really matters. That may not be so but there's an awful lot of there's another. It's like experimental design questions. Another thing is there weren't very many filler items, distractor items, and they always ask questions about the relevant names. So it suggested to us that maybe this was a memory task, that people were just trying to memorize these sentences. And part of what led us to think that the reaction times are incredibly slow. They were getting 500 to 800 milliseconds per word at the critical region. So here's our critical region, 800 milliseconds per word. That's really slow. So the slowest reaction times I was showing you are around 400 for this kind of complex. These are not very complex sentences, right? So this is just, it was the barber that the lawyer saw. So at saw in that sentence, people are reading almost a second per word, which is really slow, suggesting to us that they were doing some sort of memory task, or memorizing the whole sentence so that because they knew they had to have a question later. I mean, it's just a hypothesis. And they didn't run the pronoun case. And so we want to know, let's see what happens with the pronoun. So what we did was the same thing as they did. With our method, self-paced reading, word by word across the screen, with more conditions. So not just the 2x2 that they had, but the 3x3, also including pronouns. So pronouns, names, definite descriptions. Here's ours, just like theirs. It was the lawyer who the businessman avoided the party. All these versions. It was you who we avoided the party. So pronoun case there, always a first or second person pronoun, so there's no ambiguity there. Okay. So the Gordon's theory predicted that we should replicate what he got, definite description. When you match definite, now name, you should be really slow, and also pronoun should be really slow. The accessibility of the reference type theory predicts something really different. If you have the definite in the middle should be the worst, then the name, then the pronoun, right? The pronoun is the most accessible thing. That should be easy all the time. So it should be easiest. If you have pronoun, so that's definite, the, name, pronoun. And the same pattern on the outside. For the outside things, it should be worse to have the definite, then the name, then the pronoun. And then the inside, now you should have more effect than the outside because they're crossing more integrations. Okay, so what do we find? We find you're both right, okay? That's just reaction times across the whole sentence. You can just see a whole lot most of the stuff is going on at the verbs. Not much at the verb here. I don't want you to look at that very hard. Just show you that's what's going on across the sentence. A lot of stuff going on in the verbs. Here's his exact, just pulling out the 2x2 that Gordon ran out of our 9 conditions. This is in all the conditions we ran. So we kind of replicate, but not quite, okay? So definite's the worst, and name's pretty bad. But actually, the name definite's worse than the name. But the name is worse than the definite name. So there is an interaction, which is the interaction he got. You get the similarity effect. These two are worse than these two. So that's what he found. But we don't get, remember his pattern was these two way up, these two way down. We're not getting that. We're getting evidence of both things going on here. We're getting accessibility of the embedded position matters and the matching matters. And you notice our reaction times, we're talking about, at most 400 milliseconds, much less than what he was looking at. So people are reading these normally, not really slow. Okay, so what happens for the pronouns?
But there's matching number of syllables and everything, and yours don't. So maybe that's... Isn't that true?
No.
No?
No, those things are controlled as well. Yeah, that stuff's all controlled. Yeah, those are just bad examples. If they weren't matched, across items they are matched. It's not true for the pronouns. They're certainly matched because pronouns are always the one-syllable things, right? But the names and description length, names and definites are the same, are matched for length. frequency's hard. Names are basically low frequency, sort of. I mean, how are our corpora? They're kind of low frequency in the AP Newswire, but compared to some common nouns. So it's probably the wrong corpus to look at. It's hard to know how to count frequencies here. So this is what it looks like across all 9. So pronoun, you don't see a bump at all. Here's the pronoun here. You don't see any elevated reaction time. For the pronoun conditions in the embedded condition, you get very fast reaction times reading those verbs, the embedded. Very fast. That's fitting the accessibility pattern. You do see the bump. This name is higher than you would expect if all that mattered was accessibility. When we get nothing here for the pronoun, no bump. You generally get, what you get is, if there's a definite in the embedded position, that's these 3 are slower than these 3, which the name in the embedded position are slower than these 3, which are the pronoun in the embedded position. Yeah, wow.
It may be that the pronoun condition, that those are so different in one being second person, one being third person, that's sort of really salient difference between them.
Yeah. Well, let's move on. So, turns out in reaction time to questions, though, you get this pattern. So then we had the question at the end of the sentence. And so you actually do see his pattern here. Here you see definite, name, pronoun. Those 3 stick out. Those 3 bars stick out. So it's not the online processing where you see this, but you see it after the fact when you have to answer a question about what went on in that sentence. Then we do see his pattern. So I think this sort of, I don't know, it sort of fits our interpretation of his initial data that maybe what you're doing when he was. What we thought was maybe it's not so online. You're actually doing the whole memory task at that point. You're doing that retrieval as well, trying to figure out what the question is. As you're reading that sentence, and here we're getting those kinds of patterns. At the end of the sentence when you have to do that retrieval of, I guess it's, what Kaplan and Waters would call interpretive versus post-interpretive. This is kind of post-interpretive processing, trying to get some answer from the structure you built as you went along. Although I don't know how to quantify that, what the difference is between interpretive and post-interpretive. Yeah, Paul.
So these were names that were just single first names?
Yeah, yes.
Not
full names. No, these are all John, Mary, Bill.
And that's true for both the experiments we're talking about?
Yeah, for his experiments, not for our first one, so not way back here. When I motivated this, we actually used full names of famous people here. It was Dolly Parton, Bill Gates, Michael Jordan, kinds of things here. Not just not full names. Yes, full names, not just first names. Okay. So I don't know. So I would conclude they're both right somehow or other. So pieces of both are going right here. So aspects of both of these things are right. The Grodner and the accessibility things going on. I don't know. So we say the Warren and Gibson thing applies more immediately, whereas the Grodner seems to apply a little later. But the Grodner thing is applying online too. You are getting that definite. So the name is hurting you online as well, although it's not happening in the pronoun case. Okay, so when do I go to? I don't know when I started. I go for an hour? Is that the deal? It's 5:30
until Fred walks out.
For Delner?
That'll be a long time.
Well, that could be a while, yeah.
Your lucky day.
Well, or not. I don't know. Or maybe your not so lucky day. I can tell. So I started at what time? 4:40?
Yeah, about 7 minutes.
Okay. Well, there's a second factor, storage. And I'm not going to say much about this then. I'll just tell you that we also look at storage, not just integration. And so there's a bunch of evidence that storage matters in online, independent of integration. Here's a little comparison. The reporter claimed that the baseball player would hold out for more money. Through that bold region, we have no expectations for further verbs to follow, compared to the reporter's claim that the baseball player would hold out for more money. It turned out to be true. Exact same integrations going on. There's the same sentence in those two in the embedded bold region there, but people read that region slower in the second case here, where you have that expectation for a verb to follow. Okay, and we've got a bunch of evidence. So those are unambiguous sentences here. There's no ambiguity. Well, is there any ambiguity? Not much ambiguity. And people read that embedded clause slower than here, suggesting storage effects independent of integration. The integration is all the same through there. And we manipulate. Yeah.
Sorry, where is the slowdown in sentence 2?
All the way through. The whole way through that bold region. You'll see a 30 millisecond effect, basically, all the way through compared to the same region in one.
So 30 milliseconds per word?
Per word, all the way through. Yeah. All the way through, you tend to see this thing. Yeah. You have a question? Okay. Just stretching. Okay, there's like, and I could give you a bunch of examples like that. This is for predicted verbs. We can also look at predicted empty categories or WH pronouns. Same thing happens for predicted prepositional phrases following double object verbs in English. I mean, this is all English sort of oriented here. So, you know, a verb like gave, which needs a noun phrase and a prepositional phrase. Through that noun phrase, people read that slower than compared to a verb which doesn't need that second argument. Okay, bunch of cases. That's storage. That's all I'm going to tell you about. I want to get the Chinese because that's kind of cool. Well, so is this, but Chinese is just neat word order. Okay, so we already saw subject extracted relative clauses are less complex than object relative clauses in English. Okay, reporter who the senator attacked, that's hard compared to the reporter who attacked the senator. I mean, you may not have intuitions on this, but believe me, in reaction times, people read that a lot faster, the subject extraction than the object extraction, and you'll read those things. You know, it's a very big effect. The object extractions are a whole lot harder. You'll have difficulty answer questions about these. You know, if I ask you, did the senator attack the reporter? You'll be at around 75%, which is well better than chance, but you'll be at 90%, 95% here. Much easier to answer questions about subject extractions. Well, why is that? Now, I gave this, so I've given you this integration storage account of why that might be. Well, there's other possible accounts. So that's the resource account. There's more resources for object extracted than subject extracted in both integration and storage. But there's other reasons why subjects might be easier. Subject extractions might be easier to understand than object extractions. One is that cross-linguistically, subject position is a kind of a more accessible position. So it turns out that all languages have relative clauses, but not all languages allow extraction from all positions. And so English is a language that allows a lot of extraction from a lot of different positions. So it allows extraction from subject, object, indirect object, so obliques, lots of different extractions. But lots of languages don't allow extraction from further down that hierarchy. So including, basically all languages allow some extraction from subjects, but some don't objects. Okay, so objects are sort of further down some sort of accessibility hierarchy of extraction that Keenan and Comrie noted back in 1977. So it's possible that maybe the reason subject extractions are easier than object extractions is something about the position, the function of a subject, something like that is an easier, more accessible position. And we can't tell them apart in English. Turns out we can tell them apart in Chinese because of the word order. And another thing which we're going to be able to tell apart is perspective shift. Brian McWhinney had this idea that in subject extractions there's fewer perspective shifts. So what's a perspective shift? The idea is that when you're listening or when you're comprehending language, you take the perspective of the subject in the clause. Okay, so I take the perspective of the reporter here, and then when I go to the embedded clause, I'm taking the perspective of the subject in here, which is still the reporter referring to the same thing, subject extraction. And then I come out here. I'm always the reporter's, the subject's perspective all the way through. Compared to the object extraction, I'm in the subject perspective. Oh, I'm shifting to the senator's perspective. Oh, I shift back. So there's a couple of shifts of perspective. It's kind of a stipulative idea that you're taking the subject's perspective, but it actually, it gives the right effect in English. What's cool about Chinese? Well, it's got a very different word order, which I was telling you about. So it's still SVO, subject, verb, object in main clauses, but the relative clauses come before the noun phrase, before the head. So an object extracted relative clause has this kind of format. You have your subject, verb, the empty element here, and then there's a marker, some sort of complementizer or something, some kind of marker that tells you I had a relative clause, as compared to a subject extraction where there's an empty position. There's just nothing, and then you get a verb and an object and a relative marker. Now, the key thing here is, well, the perspective shift and the accessibility idea make the same prediction they always make. Basically, they say subjects are easier. Subject extractions are easier. So still, this should always be easier. Subject extraction should be easier. I'm in the subject perspective. I never shift from this guy's perspective. That's this person all the way through. Or this is the most accessible extraction. Accessibility. It's the subject extraction. That's easier than an object extraction. The interesting thing is the resource theory makes the opposite prediction. So that here, object is more local. Object is right beside the verb, beside its head noun. Subject's further away. And both storage and integration give rise to that thing, then the object extraction should be easier than the subject extraction. So that's why we tested it. And that's just the syntax, some part of the syntax of a particular item. It's always like the tycoon, it's the official who the tycoon invited had bad intentions. Okay, so the way you say it in Chinese is tycoon, invite, relative clause marker, official, had bad intentions. That's the object extraction. Again, the position here is local to the head noun. And the subject extraction just further away. Okay, and there's more storage involved here as well. You know as soon as you get to the verb and the noun that you're expecting, this is going to be some sort of relative clause. I'm going to need that head noun. There's more ambiguity involved. Oh, I'll come back to that in a second. Oh, those are just the items. If you speak Chinese, those are our. This is Taiwan Chinese, not Taiwanese. No, Taiwan Chinese. Yeah, I called it Taiwanese, and she gets mad. It's not. That's not the same thing. So anyway, yeah. So those are the theories. Resources make more subject extractions should be harder than object extraction. Accessibility perspectives say they should be easier still. And I want to note there's a temporary ambiguity in the object extracted relative clause, but less so in the subject extracted relative clause. And so if any, so let me just point that out. So what is that? In the object extracted. So that's this one here. So in Chinese, this is ambiguous. I get a subject and verb. I think I'm probably in the main clause here. And then I get a relative marker. No, it's a relative clause. Okay, so this is ambiguity, a lot of ambiguity in the object extraction. Much less so in the subject extraction, where I don't get anything here, and I get a verb. So I think I'm probably in some kind of embedded structure, a relative clause. Chinese does allow null pronominals, so it's a topic drop language. So it's a topic drop language. So logically this could be the topic, but these are null contexts. I mean, these are just single sentences in null contexts. And none of the material, it's very peculiar. Okay, it's kind of peculiar in a null context to have a null topic. So that's a possibility. It's just kind of it's also true in the other one. There could be a null object there as well. It's sort of the same across both. Probably there's not much ambiguity here. You take this as the relative clause verb and the relative clause object. So there's more ambiguity in the object extraction. So if the resource theory is right, it's in spite of ambiguity. That's not a confound. That's in spite of any temporary ambiguity, it goes the opposite direction. And that's what we found. So what you find is the subject extractions are actually harder here at the embedded verb. Subject extractions are, well, I'm just giving you the reaction time data. People read them slower than the subjects. So this is the object extraction, it's faster than the subject extraction. Right through the relative clause. Oh, that's just details. And we also ran doubly embedded versions. So like the English doubly embedded versions, we ran doubly embedded versions in Chinese. And here the subject extracted versions are doubly nested now, not singly nested. So I can show you the trees, the phrase structures. So this is the object extractions. These are kind of easy. Okay, these are intuitively kind of easy. Boss trusts secretary, secretary likes engineer, engineer works very hard. So in English, that would be a really nasty sentence. It would be the engineer who the secretary, who the boss trusts, likes, works very hard. But because the relative clause comes before the head, it's actually a left branching structure, which is easy. And this is the subject extraction version, which is really intuitively very bad in Chinese, but it would be fine in English. Basically, there's long distance dependencies here between these two subjects and their relative heads. And so the reaction time data are, as we kind of expect in terms of resources, the subject extractions are a whole lot slower than the object extractions. That's the reason you don't get anything there is because in one case it's this really short function word, the complementizer de, and it's a full noun phrase there. And so you can factor out, that's what this says here, just getting rid of word length control, computing residual reaction times, just getting rid of, and then you see all the way through these things, you get these much slower for the subject extractions compared to the object extractions all the way through. And it's the same words, the same, we control for plausibility, these are the same verbs and nouns in the same relationships, just in a different order, just like the English case. Okay. So resource theories predict this. The accessibility perspective shifts don't. Oh, and there's actually some consequences for representations in Chinese. So there's probably no operator on the left if you're interested in that. If there were an operator, then we still have these long distance dependencies, which would make things just equally bad for the object extractions. The object extractions would be just as bad because you would have this long distance dependency there. So there probably isn't any operator over there. Okay, I'm done. Local conclusions, storage integration applied, accounting for lots of processing of lots of stuff. Unambiguous and ambiguous, all I told you about was unambiguous structures today, including online reaction times, complexity of nested structures, a lot of other stuff, high complexity of some two-clause ones. Nesting, in English and Japanese, I didn't even talk about that. Heaviness, and lots of ambiguity effects, which I didn't talk about. So sentence processing in general, there's lots of factors again involved in sentence processing. I didn't really tell you again about how they interact. I just concentrated on this one syntactic structure, and I think you should keep dependencies close if you want to make it easier on your reader, easier on your listener, and minimize your predicted categories. And then there's all the other things which we'll figure out some other time. Okay. Or actually other people have. Are there any questions? Yeah, easy.
So you consider the possibility that the subject-object asymmetry may be due to the fact that subjects are more extractable than objects, and then you discount that possibility. Right?
Yeah.
But see, it's not really true that subjects are more extractable than objects, at least in English. So we have WH Island, for example, subject extraction is really possible, but object extraction is kind of okay.
Right.
So the book that you wonder when I read is Moby Dick. It's kind of a little bit minor. But the student you wonder when read the book.
So there are these asymmetries, subject-object asymmetries, which go in the reverse direction. So cross-linguistically in island phenomena, subjects are weirder, or subject extractions are stranger. I don't have anything to say about that, other than this was just like an alternative, right? I was raising an alternative explanation. That wouldn't account for.
That's additional reason to discount it.
Oh, okay. Okay, another reason to just okay. I'm always happy to have more reasons to ignore things or to learn something. Yeah, Jason.
Yeah, it would be interesting to look at hand parse corpora of English and Chinese to see whether, and maybe you already know this.
No, we have. We started doing this. So we got the hand parse Chinese corpora.
Okay, so is object extraction more common in Chinese?
Well, in our initial analyses, no. The subject extraction is actually more frequent still. The subject extractions are more common than the object extractions.
I believe that.
So there's some, I don't know what that means because I've looked a lot at
is the ratio the same as in English? Or is there some functionalist push?
Maybe. So the English is a high bias. So Doug Rowe did a lot of corpus counts on these in English for a whole bunch of different wrong clause and other kinds of construction counting. And subject extractions are far more common than object extractions in English for relative clauses in terms of frequencies of the structures. In Chinese, there's a parse pen tree bank. Chinese, there's a Chinese corpus there, which is parsed. And so we pulled out all the object and subject extractions there. And there's still more subject extractions than object extractions. I don't think the frequencies are as biased as they are in English.
Well, that was the question. You would like to see some effect that the speaker is trying to make things easier for the hearer. Which is, lots of people suspect that speakers do that, but I haven't seen that much evidence bearing on the question.
Well, I don't know. They're written corpora, they're not spoken corpora. It's hard to, so they may be written for.
There's a real question whether people do it in speech, even if they do it in music writing. So that's the question. There is a lot of a question about whether people in production take account of their listener and their reader. It's a big open question.
And some of your factors would affect planning or production as well, right? So if you're making predictions.
Yes,
that's right.
That's absolutely right. Yes, so some of these factors would apply. So the explanation could be in production end, is what you're. So part of it's in fact some of these explanations might apply.
So differences in the relative frequency of subject and object relatives could have nothing to do with altruism towards your.
Right.
You're quite right. I withdraw the
That's
question.
right. That's right. Yeah. Yeah. Paul?
So, I don't normally like to worry about naturalness, but something about the contrast that you're talking about here raises some kind of flag for me. It's normally the case in a discourse appropriate context that you say John, there's a clear referent.
Yes.
That's certainly not the case here.
No.
Right? And the thing is that first names are completely unimageable, completely impoverished and arbitrary compared to any other kind of description. So if I say the lawyer, blah, 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 it's infinitely easier for me to start building representation than if I just say John. It's especially the case if you have two different in the cleft examples. You've got John, you've got Bill. They're completely arbitrary names. You're going to ask me a question, was it John or Bill later? And that's a hard question. If it's the lawyer and the actress, then at least I have a little bit of a head start in trying to distinguish those two actors, those two participants in my representation. So I wonder if the assumption that these first names ought to be considered discourse somehow more accessible than descriptions is really appropriate in this kind of context.
Well, I guess I just want to point out that, so your intuition is backwards of what actually happened. So your intuition is that it should be easier to process something like the lawyer in all context than a name like John, right? But that's not what happens. It's the opposite what happens. People actually read the names faster, even when you control for word length. The names are, so, you can have that intuition, but I think it's wrong. And so,
but it's not wrong about the question answering part, right?
No. But the online reading time stuff, you're getting faster reaction times for the names. These three are faster than these three for the definite. So your intuition is not fitting this pattern.
Let me start over again.
Yeah.
There was a funny result which you didn't expect.
Yeah. What was that?
From the.
I didn't expect a lot of these things, but after the fact.
From the bad guys experiment. Come on.
Yeah. Oh, okay. Yeah, okay. Sorry. This one?
The bad guy experiment came out wrong. And I'm trying to tell you that if what you said is true about the conditions of the experiment producing a kind of set, right? I just heard the experiments. It was John that Bill saw in the parking lot.
I see.
I'm going to be asked, who saw whom or something.
Yeah.
And I know that's coming up. It seems plausible to me that it's more difficult to create a representation for which I can reliably give you an answer to that question than if you say it was the barber that the lawyer saw in the parking lot.
Yeah. But then when you expect the description ones to be elevated in some way. You don't see that either here. All they see is a match-mismatch effect. So you just don't see what you're saying. I get the intuition, I get your hypothesis, I just don't see it in the data. In the comprehension, you see it? Names are the worst, description. I don't know, I can't, hard to make something out of that. So these are object extractions. So name, you're doing worse than description. Yeah, I don't know. Yeah, there's error bars there. So you're accounting for this one here maybe, for being elevated over these in the answers.
You're not convinced?
Well, my brother's name is John, so I would remember immediately.
I don't know. It's a hypothesis. So we could do the same thing in contexts, right? In fact, that's something we plan to do, where you set up a little context, a discourse with some people's names, which is, and we just run the same thing and see. Generally when we do that, when we've done that kind of thing before, you see the same effects but smaller. So it would be bad if that wasn't true. Then, if that wasn't true, if we didn't see the same effects but smaller, then what we may be seeing is something peculiar about null contexts, right? Something odd about null context and it's unnatural context. But I haven't presented those data to you. But generally, when we do that, you do see the same you see the same patterns, but the effect sizes are a lot smaller. But you see the same. You have to run more subjects, more items, but you see the same patterns. I don't know if that would happen, but we actually are planning to do that with multiple. So you set up a context with two names, set up a context with a name, and make them more felicitous. Right. So the lawyer was talking to John. A lawyer was talking to John about blah blah blah, and you got to set them up, make it more felicitous than that. You got to if you're going to use relative clauses, we've got to have, oh, these aren't relative clauses. We've got to have some plausible, no, that's okay. So in these cleft kind of cases, you can say that there's a barber, I don't know, some context with the barber and John, or the barber and the lawyer or something in them, and then say it was the barber who the lawyer saw in the parking lot. Somehow or other, you can try to make those more felicitous. And we should see, it's an open question. Whether I would guess we'll see the same kind of things as we saw before. Not this one, because I don't like this method. As this, we'll see. Well, I would guess we'll see something like that in reaction times. But I don't know. I haven't done it. But that's one thing we want to do, to rule out that as a possible worry is the null context driving the effects.
So in a similar vein, is there, you believe that the definite versus indefinite MPs is a real distinction?
Yeah, well,
in the context of, in a null context?
Yeah, I do. Yeah, I mean, I don't know. That's, who cares what I believe? That's an empirical question, right? But I do. I think that's a very plausible hypothesis that indefinites are worse than relative clauses than the definites.
And finally, so if you said, I'm going to tell you a bunch of things about Dolly Parton.
Yeah.
When she was young, Dolly Parton liked this, right? And you contrast that with some other kinds of referring expressions. So the discourse entity is already introduced. According to you, Dolly Parton should be pretty much the same as she, right? Yeah. And you think that's how it would turn out?
So what are you doing there? You got to do it naturally. So it's kind of weird to say, I'm going to tell you a bunch of things about Dolly Parton, and then go, Dolly Parton did this, and Dolly Parton did that, and that's very peculiar.
I know it's weird, but it's not as weird as just coming out of nowhere talking about
Well,
Dolly Parton.
there is a repeated name penalty. So you'll get, that's something that Peter Gordon in other kinds of experiments has shown, that you get repeated name penalty. So when you should be using, when you've got a mental model and you've really established a referent, you really should be using a pronoun there. And if you don't use a pronoun there, there's a penalty for it. And
I know you have to work a little bit. That's why it's a job to be experimentalist. So you might have to say something like, okay, I'm going to tell you a bunch of things about Dolly Parton and... So that it's not so highly accessible. So then so it's appropriate. Yes, we make that prediction. You could introduce Dolly Parton and I don't know, George Bush. You could refer to one by she as one as he, or you could use the full names, and you could see whether there really is. It's the discourse entity status that matters, or it's the referring expression status that matters.
Yeah. That's the kind of thing we want to do. We are doing those kinds of things, not all of them. John Hsiao?
Following my advisor, I want to ask another question about the bad guys, about the post-interpretive processing interpretation of the Gordon data.
Yeah.
I'm very partial to this, and I'm wondering if you are too. Do you think that it supports this idea that the Gordon thing is post-interpretive, that there's been so much success modeling the similarity data by using cognitive architectures that operate in a more cognitive and inferential band, that are talking about more generalized problem-solving activities, like act?
You've got a lot of presuppositions there. Yeah. So what are they? What are your presuppositions? So you're saying there's something that Gordon, so there's some modeling results which you're assuming, which I don't know. So what are you talking about there?
Okay, so there's an interpretation that what's going on in this data is two factors. One is interpretive and post-interpretive.
Yes.
And it's my presupposition that this similarity data has been well modeled by production systems work by Rick Lewis and Julia Van Dyke.
Has it been well modeled? So I didn't know that. So you're saying that the Gordon stuff has been modeled somehow or other?
Well, not exactly the Gordon data, but the same similarity of NPs. I mean, Charlotte had like 3 posters on this.
Okay, this is a recent stuff at the CUNY conference he's talking about. So,
right.
But those are different. Rick Lewis's similarity is different from.
Oh, you think it's very different?
It's different because he's talking about. Rick Lewis is talking about similarity of the predicted category you're expecting. So it's the similarity of the.
It's retrieval. It's retrieval, as I understand it.
Well, my memory of his stuff was that multiple subjects. Multiple subjects are the same case, so you're waiting for multiple verbs, and that hurts you. So the similarity of those things hurts you. But that's sort of storage in my stuff. That storage, that's like the number of predicted heads would hurt you. I mean, if I just don't, I don't know how to answer your question because I don't know the data you're referring to, And I don't know how to, I don't know. Interpreter, post-interpreter is very nice, a hand-wavy idea. So this is Kaplan and Waters. They have this idea that there's interpretive processing, processing you do online as you're listening or hearing. And that's what makes a nested structure hard. A nested structure is difficult because of the interpretive processing you do, and it's very difficult. And post-interpretive is like going back to that representation and trying to do something to it, like remember it, you pull pieces out of it. But it's very hard to formalize that because you do those kinds of things in interpretive processing.
But it might be
and so it's
operationalize it, and it takes longer. It's a longer time scale. And I'm asking your opinion of the idea that a larger time scale cognitive architecture might be more appropriate for that.
Yeah, maybe. It's possible. I can't, I think we need to I'm sort of hesitant to talk about interpretive, post-interpretive until I formalize it. And I don't think it's formalized in the Kaplan and Waters. I mean, that's why I was being very
John just told you, if you see 800, 900 millisecond reading times, then you're doing post-interpretive processing.
That's not good enough for me. I need the definition of what it is. Sorry.
Have you looked at German at all? Because
not intentionally.
Not intentionally.
No, yeah.
Because,
we have some German speakers.
It ought to be a language to check, test the locality effect, having to do with the position of object and subject with respect to the verbs. Given that on the surface, the word order is different in main clauses and in embedded clauses. You would get some interesting combinations, I think, that would be a good domain.
Well, we have actually looked at, it's not this, Japanese, lots of online reaction time stuff in Japanese where you get, it's a head final language like German, but it doesn't have that movement property. And I can tell you about that. I was going to tell you about that, but I was already, I realized there was no hope of doing that. I mean, there's lots of interesting things to tell you about there, which I think I should leave for later because it would take another 15 minutes to really explain. But I mean, lots of people have looked at German and Japanese and head final languages. And it's not so simple. This integration story, I'm telling you, wouldn't that be? You should see longer reaction times on verbs, basically, if you have more dependence or longer dependence there. Well, you don't see that. You don't see that. And so why don't you see that? Well, is the integration idea wrong? Or well, maybe not. Maybe it's because we're doing those integrations earlier. I mean, there's a lot of incremental processing going on, presumably, in Japanese and German. And so you're actually building a lot of that structure partway along. And so it's actually not it may not be a long distance integration at the verb. You end up with a very local connection sometimes between all the stuff you're predicting and the final verb. And so it's not like lots of evidence across sentence processing literature has shown that we are doing incremental processing. We are not waiting for heads to do processing. We're not like waiting for the head to do. We actually do it. We make guesses. We're making all kinds of guesses, and so that's probably going on in these verb final languages too. But there's a lot.
Why is it going on in English? I mean,
well, it is going on in English, but when you get interrupted, when the dependencies, which stuff that comes in between, which is not relevant to your. So all the cases I was showing you, you've got like a subject and a whole bunch of junk, which is not the subject. It's no longer a direct dependent of that verb. That slows you down on the verb. In these Japanese and German cases, the last thing before the verb is always a dependent of that verb. And so you're basically building up structure, which is, and then you see no slowdowns you see fast reaction times, basically.
I mean,
But we were still looking for cases where you see locality effects in like moved cases where you don't have dependencies. Japanese is really messy because it's so ambiguous. It's so hard to look at ambiguous structures. So, but German may be better. Yeah.
I remember when I was learning to become a translator, parallel, I was hearing German and I was translating into French or English. You couldn't wait until that verb showed up. So the effect you have to integrate earlier. Otherwise you'd be lost.
So you make a guess? What do you do? Make a guess?
Yeah.
You just make a guess with the verb. Well, that's interesting. To the extent that you can do that, that's.
You have to know the context, what it's about.
To the extent that works, that's very informative. It's like, why bother with the verb at the end at all?
You made a correction, slight correction at the end.
Is there any data
it was nuts. It was really
I want that. Can we get transcripts of simultaneous translation?
Yeah. There must
I'm serious. If we can't, can we hire somebody like you, for example?
No, it's a long time ago, Jason.
Yeah.
And it was very difficult.
No,
to
but
imagine.
I can imagine. But in principle, we could hire somebody who's
Yes,
who does it for a
well,
living.
you know, go to the European. They have simultaneous translation.
Yeah, or the
in all
UN
these
is closer.
international
Yeah.
Would
conferences.
somebody who's doing Japanese who puts, or they put the negation at the end, would they make it guess at the beginning?
Yeah. I don't know. Intonation, I hope.
It must be very good, very
Yeah,
heavy.
really.
I've heard of the introduction to English of the not.
Yeah, exactly.
Yeah,
It's
yeah.
introduced by simultaneous translators.
Yeah.
That explains it.
Yeah.
So I want to ask a very high level question. In a sense, the account that you presented, while it's extremely nice and extremely intuitive,
Yeah.
right, is also counterintuitive in the following sense. It fits the data. I'm not denying the account. But the question is, what kind of cognitive architecture would lead to a system where you measure the distance in terms of words which are no longer available? So, in other words, why should all this junk in the middle, which you've already packaged up into a constituent, and which, except in Dutch, where you have cross-serial dependencies, you're not allowed to link, or scrambling, case where you have scrambling.
Yeah.
If you're not allowed to link into that, if they're just unavailable dependencies, why does it slow you down? So I can think of a few good answers, but I'm wondering whether sort of what your current thinking is about what the architecture would be.
Yeah, well, I sort of skipped that slide. That was the very first slide on integration, which I sort of just stepped over, which is, why I think this is the hypothesis is that, sort of my thinking of that is it's a working memory-based system where it's a retrieval thing. So I'm trying to retrieve. The integration later is the more stuff I do in between. So I process some sentence, I'm listening to some sentence, and I build some representation for subject, say. And as I hear stuff which is irrelevant, my representation for that subject is going to degrade in some way because of the interference or decay or something of all that stuff I heard in between. And so it's a retrieval problem, pulling that thing out again. That's the story I tell. That's the motivation. And so the more work I have to do in the interim, the harder it is to do that retrieval. And so that's why it matters. That's the hypothesis.
Yeah, so this is also the picture I had in mind. I wonder what else one could do in order to demonstrate that.
I don't know. But there's an alternative which I haven't really explored at all here, which is totally fits as well, which is what you're doing is matching frequencies of input, right? So another alternative, so the Mary-Ellen-McDonald hypothesis, which is very hard to test. Maybe the Chinese data will help with some dissociation between frequencies and complexity if that ends up being true. But if there is a good match between the kinds of structures which occur in the input and the kinds of structures which are easier and hard to understand, then maybe what you're doing isn't an induit, it's sort of activation, reactivation. It's just, I've seen that kind of thing before. I'm used to those kinds of structures. So then you're stuck with, well, why are those
structures more or less frequent?
Yes,
yeah. But that could come from production.
Exactly, that's her story. So it comes from production. So now it's everything I've said it has to apply somewhere in production, not in comprehension.
Right.
But that you might end up with a different production theory. So maybe you have to quantify that and work that out. It's really hard to pull those apart, though. This activation idea, working memory idea, from the frequency matching story. There's a really difficult. There's unless you happen to find cases where the frequencies don't match, they make the same predictions pretty much.
We need to find babies so we can control the input.
Yeah. So that's what they do. They do the babies. They do undergrads and try to train them on lots of structures. But that's also plausible. There might be some structural priming, structural stuff going on, even in the working memory architecture. So that's not really going to show one thing right or wrong either. But it's nice.
Can you explain just a second what you meant by that? So
Yeah.
the alternative to saying that
Yeah.
if there's a bunch of discourse entities introduced
Yeah.
between
Yes.
a subject and a verb, it makes it harder to
Yes.
do the binding.
Yes.
The alternative is that something about frequency.
Something about frequency.
Is
So
it supposed to mean that the frequency with which a verb binds to something that was 12 words earlier is a lot less than the frequency with which a verb binds to something that was 3 words earlier, therefore it takes longer?
yes.
Just checking.
That's
Yeah,
That's
Or
exactly
what you're
it.
doing is you're imposing
Yeah.
some more complicated structure. So
Yeah.
instead of saying that the fundamental objects in the compiled version of the grammar that you use for processing are context-free rules or word-to-word dependencies, that in fact you're imposing some more complicated structure which has to sort of match the lower level stuff and add the new higher level stuff. Did that make any sense?
No. Can you restate that, Jason?